Okay, Murari, let's see how to answer your question. The question is a metal M reacts with O2 to form oxide M2O3. 0.359 grams of M reacts with O2 to give 0.559 grams of oxide. You need to find the atomic weight of M. So step 1 is to actually stick in a balanced equation, and that's your balanced equation over here. 2M2 plus 3O2 gives you 2M2O3. First, let's compute how many moles of oxygen are reacting. So if 0.559 grams is oxide formed, of which 0.359 is the metal, the difference, which is 0.2 grams, is oxygen by mass conservation. And therefore, the number of moles of O2 is 0.2 by 32. Now, 3 moles of oxygen form 2 moles of the oxide from this balanced equation here. And therefore, this number of moles, 0.2 by 32, will form 2 by 3 into 0.2 by 32 moles of the oxide, by stoichiometry. Now, this number of moles which is formed, as we discussed, weighs 0.559 grams. Therefore, 1 mole weighs how much of the oxide? And that's a straightforward calculation. 0.559 times 3 times 32 by 2 into 0.02. Now this amount of oxide, 0.559 grams, has 0.359 grams of the metal M. Therefore 1 mole of oxide, which weighs this much, will have 0.559 times 3 times 32 divided by 2 into 0.2 times 0.359 by 0.559 grams. Okay, this is the mass of metal contained in 1 mole of the oxide itself. Now, if you look at the formula of the oxide M2O3, 1 mole of the oxide has 2 moles of M. Therefore, 2 moles of M weighs this number that we previously calculated, and I've just cancelled the 0.559 in the numerator and denominator from the previous page. So 3 into 32 into 0.359 divided by 2 into 0.2 is the mass of 2 moles of M. Therefore, mass of 1 mole of M is this number here. If you solve, you will end up getting 43 grams. Let me know if you still have a problem.